I started it then. Okay.
What is it?
Thank you, Ari.
What is it?
Okay, and so this is the agenda for the session. So just some introductions. Our plan is from Tom from ARDC to talk about the work that they've been doing in line with their national agenda for research software. Maureen from Software Heritage has kindly joined us to talk about relevant developments in software citation. Thank you, Maureen. And then we're going to talk a little bit about provide a brief introduction to Scholix for those of you who aren't familiar with it, and then raise the question of how Scholix could support software citation from different perspectives. And then said the real reason of having this joint session was to get input from the community, from folks who've worked in Scholix, and also the software community on this. So so we'll have time for some discussion on that, and we'd really welcome your input before we close. So what I was going to suggest, if Tom isn't here and I can't see him in the list, Maureen, I'd probably ask you to go ahead and start and saying you're here, you're ready, you've got your slides, and there's not sort of a need to have one before the other. So are you happy to do that? Excellent.
Yes, no problem. Just let me open up the slide deck that I have. And I'm going to share the screen. So just a second. Can you see my screen?
Yes, thank you. That all works.
Yeah.
Perfect. So first, thank you for inviting me to join your session, the joint session for different working groups. I think I represent also the software source code interest group, since I'm one of the chairs of the working group. But today I will do a few slides about software heritage, but also about how to archive, identify, describe, and cite software source code with the French National Archive, HAL, and with software heritage. In this few slides, I have some examples on citation exports possible with these infrastructures. So let's start. For those of you who do not know software heritage, it has a very big, ambitious plan and goal. It is to collect, preserve, and share all software source code to enable better software and better science for all. It's a non-profit organization launched in 2016 by INRIA, and it archives today all publicly available code permanently and for free. The plan is to archive be the universal source code archive, so not only publicly available code, but today it's what we are able to do. It's a recent project. To give you some idea of the community that's backing software heritage, so we are hosted in the INRIA Research Center, and we have UNESCO as a full partner and some different sponsors, diversity panel of sponsors. One of the missions, important missions of software heritage is to rescue code. So you might ask yourself why it's so important. So software source code is fragile. We have seen that recently with Google Code that closed. It was a forge with many repositories, and also more recently, mercurial repositories in Bitbucket have been closed as well. You can only use Bitbucket for Git usage, and those repositories are also safely saved in software heritage. Now, I'm Normally, I have a very long presentation describing why it's important, but I'm going to go straight to the important matter here, which is linking and identifying and referencing artifacts in the scholarly ecosystem. Software heritage provides a persistent identifier called a SWID, SWHID, which is an intrinsic identifier intimately bound to the object. It's like a fingerprint. And so on the slide deck, you have this blog post, intrinsic versus extrinsic, while most identifiers in the scholarly ecosystem are extrinsic, which are given by a registry. The software heritage identifier is really produced by the element itself. So you can calculate your identifier in your on your machine. You don't have to have software heritage to do that. And there are different types of identifiers for different types of artifacts. So it depends on the level of granularity that you want to reference. So you have here an example on the slide of a content, which is a file, but you can have another level, which is a snapshot, which will include all the branches and all the releases, a release, a specific revision, which is a specific commit in the development history, a directory, and a file. And lastly, you can also identify a few lines of code. Here you see it with this parameter. This will get you directly to the specific algorithm, for example, that you want to reference. So I haven't said that before, but also software heritage archives all the development history, not only the code of a specific version, but it really clones the full repository with all the branches and all the history that goes with it. Here we have a few examples that you can play with. I saw that the presentation is linked on the document, so you can go to the presentation and go play with these SWIDs, with these identifiers. And I'm going to continue to explain a little bit about software and research. We have different facets, where the software has different facets. It can be a tool, it can be a research outcome or a result, or it can be the object of research. And all these facets are complex. What is important in the research ecosystem is linking between all the different research outputs. So you can see on the right in this diagram the three main pillars with open datasets repositories, open access repositories, and open source repositories. The links are very important to give credit and to acknowledge the resource that was made. So we know that there are different needs from different types of actors in this ecosystem. We have researchers that want to archive and reference for their own used software or their own created software. They want to find useful software, they want to get credit for the software they developed, and when they want to verify or reproduce or improve even the results. And in parallel, there are research organizations and laboratories. So the research organization want to know the software assets with the metrics and to inform the strategy. And the laboratories and teams want to track the software contributions, produce reports, and maintain web pages. All of these needs are very important and should be kept in mind when providing identifiers. What is at stake? We have, as I said on the first slide, 4 actions that we do want to make sure is possible with this infrastructure, which is archive, so that the artifacts do not disappear. Reference, so we have a proper identifier to the artifact itself, not only to a record containing metadata, but also to the artifact itself. Describe, these artifacts should be described with correct or quality metadata. So it will be easier to discover them for their visibility, but also to keep the context of these artifacts. And finally, cite, and this is the most important, but also most difficult, because we want the software that was created in research and is used in research to be properly cited, to give credit to authors for proper evaluation. So the solutions that propose HAL and software heritage are two different solutions and one combined solution. So we have what we call the classic deposit here on the left, where you come to HAL, the HAL National Archive, and you deposit a zip at RDA. Yes, I heard someone. Maybe a question? No.
No,
Okay.
you're okay.
Thank you. And you have on the right side of this slide the save code now that I will show you just after this slide, which is a feature provided by Software Heritage to save a complete repository. And those two options are valuable with some differences. So for the submitting code into HAL, it's a scholarly repository. It's also an archive, and the software will be more findable by being on HAL, and the code is transferred to Software Heritage. And on the other side, having a save code now to Software Heritage, it's really easy. You can submit a repository which is not only yours, with the complete development history. And there you have a PID referencing the specific pieces of code, even algorithms. And in the middle, you have this new coming soon Sweet deposit, which is now in beta testing on one of the HAL instances, where you are not depositing a zip file. You just take a SWID after doing a save code now, and you put it on the form when submitting the code into HAL. So we are working towards a better workflow for researchers to, when they develop their software, then they can archive it in Software Heritage and in HAL. So I won't take much time about this slide about the collaboration. It was a fruitful collaboration, but what I want to show you is that a few months ago, we released a tutorial series on YouTube about open science, specifically on the source code deposit. It's very short videos. It's about 7 videos, each one 5 minutes. So if you're interested on discovering how to deposit on those infrastructures, this is the place to get this information. Quickly, I will show you how it works. So the researcher is coming to the platform, the HAL platform, splits code, and then there's a moderator, a digital archivist that will verify the deposit by verifying specifically if the metadata deposited on the record are coherent with the ones that can be found on the software itself. So there are a few files that are mandatory, a README is mandatory, a license file is mandatory, and an authors file. All of those files are mandatory and are checked by this digital archivist on the HAL platform. After that, the deposit is validated or not. There can be some discussion between this moderator and the researcher. But at the end, after this review process, it will be validated and be saved in HAL, and we'll get this extrinsic identifier, which is the HAL ID, which is similar to a DOI, and also transferred into Software Heritage, which will give you a SWID, a Software Heritage identifier for the specific directory that was deposited during this, process. So before going to the SWID deposit, which I will show you, I just wanted to explain how easy it is to save your code or any code with Software Heritage. You choose the origin type, you have the origin URL here, and then you submit, and you can choose any URL that you want. It's a little bit like the Internet Archive. So if you have important software that you want to make sure that it will be archived, this is the way to do it. And so moving on to the SWID deposit, which is more interesting in a collaborative project where there are many researchers and contributors in the project. Here I am just realizing that the diagram is in French, but I think that you can understand with the picture as to how it works. So you have the researchers here on the left, like the other diagram, and here you have a team of researchers, and here you have contributors, which are external contributor working on version control system. Then when it's saved in software heritage, the full development history is saved, a SWID is accessible. The researchers will choose a SWID, will submit this SWID and some metadata into HAL, and then the review process will be the same with the moderator or digital archivist. It will be validated and then accessible also on HAL with the extrinsic identifier and on software heritage. So to explain why I've presented all these items before coming into the subject of our of this joint session is because of the identifiers, the types of identifiers that are different. Here we see the citation format that is provided on the HAL interface, including both identifier, one for the research product identifier and one for the source code identifier. It's important to have both because one, which is the extrinsic identifier, is for credit and attribution. It will identify the record and will give credit for the authors, while the other one is not made to do that. It's really to identify the software source code itself. And if there are, so we prefer having metadata on the software source code, but sometimes the metadata is not available. So it's important to have the record and the code. And so for reuse and reproducibility, the SWID is more important as the specific fingerprint of this code. Then we have the citation export in HAL. We do not have citation export in software heritage yet. So this is also a good advantage of this collaboration between the French National Archive and software heritage. This citation will be accessible on the HAL record. There's an export with the type software, bibliothèque type software or software version if a version was properly submitted. And this export was also used for activity reports in the INRIA Research Center, but it's something that we want to try to export to different organizations and institutions in France. So here you can see how this BibTech well, how it looks. We have the authors, the title, and the identifiers. So I've told you that there are some files that are mandatory. So here you have the mandatory files, and the code meta.json is not mandatory but useful because you can use it in the SWID deposit and it will populate the form automatically. Why code meta.json? So we need a full presentation only on that. So, but shortly I can tell you that it's an academic community discussing software metadata. It's a subset of schema.org, and there's a very impressive crosswalk table mapping the metadata landscape describing software. There's a hosted version on the code meta site, and there is a code repository of this code meta generator, which is a tool where you can create your own code meta.json file. A few types of software metadata terms to identify, to administrate, to classify, and to execute software. These terms are taken directly from the code meta vocabulary, but you don't need to use it all. It's just to show you what we can use as metadata when we talk about software. Moving on to another subject, which is the citation.cff, which is another perspective. This is something that is available on GitHub today. Citation.cff is also a vocabulary specific to citation. The properties, there's not a lot of properties, but they are very specific to citation. And now this export on GitHub, when you use the citation.cff in your repository, is with this BibTech software type. I'm also noting that citation.cff files are also indexed in the software heritage archive. So all these intrinsic metadata files, certain types of intrinsic metadata files are indexed in software heritage, which will help with the findability of software source code. To connect that to the FAIR question, so this is a slide I've shown also in the presentation we had for the FAIR for Research Software Working Group. I'm a chair, and we have finalized the work this late, just before we had the last session. But I wanted to show you this slide, because FAIR is just not enough for software. So if you want to have software reproducible and archived and open source, this is not part of the FAIR principles. And so you can see on this slide from left to right that it's increasing. So it's better to increase the level of fairness and go beyond the level of fairness by adding an open source license, having the source code archived. This is the little logo of archival in software heritage. And we will not discuss this today, but there are other things that you can do with documentation and having the environment available to make it more reproducible. To sum up, I'm proposing here a few actions that you can do even today to better the research outputs in your institution. First, archive your code. You've seen if it's developed in a version control system online, it's very easy. Describe it with intrinsic files, with a README, a license, and authors file. This is good practices from the community, but also using a code meta.json file is useful. Using a suite to reference a specific source code artifact, but to cite your code, you need both extrinsic and intrinsic identifiers. So here we propose the HAL ID with the French National Archive, but we have also the possibility to have other extrinsic identifiers like the DR. So thank you very much for your attention, and I will stop sharing now.
Excellent, Maureen. Thank you. Yeah, thank you very much. I think we've got a few minutes if anyone has questions. I can see that there's a question in the shared document asking if you could share the YouTube with the short tutorials. If
Yes,
you'd be
sure.
able to share a link to that, then there's an ask for that, and I think people will be really grateful.
I will put it in the chat, but you can also know that there's the link on the presentations itself. But I'm going to put the link in the chat. It will be easier for everybody.
Excellent, thank you. Does anyone else have questions? Again, we should have time at the end as part of sort of discussion too.
In that case, I think Tom has joined us now, so I think maybe we first go to. We have the discussion at the end following the three presentations.
Yep.
So yeah, thanks again, Maureen. That was a really great overview, and I see Tom has switched his video on, so I think he's ready to.
Sorry about that.
To share some thoughts on software with us.
Now I am just struggling because when I go to share the screen, all it shows me is Google Chrome unknown for all of the different windows that I have open. So just bear with me for a second longer so I can get my screen shared. And I may share the wrong screen to make this work. Apologies in advance.
No problem.
Okay, so honestly, I promise you, I use Zoom all the time. I know what I'm doing and something weird's happening. So yeah, I am actually going to share a screen and ask you if it's the slides because I cannot actually see what's.
That is quite all right. I had similar weirdness happen yesterday.
Okay. All right, I actually have to leave and rejoin, sorry.
Okay, cool.
Okay, we'll give you a minute.
Yeah, Lars, we agree. Many have had that weirdness happening.
Yeah, while we wait for Tom, Moraine suggested in chat that you can play with Software Heritage Archive.
Also, if there are questions that you wanted to keep for the end, don't be shy. You can jump in and ask the questions. Oh, here is Tom. So never mind.
Sorry, everyone.
Hello, Tom.
It shows up. Brilliant.
Good.
Excellent. No, I think Lars has mentioned in the chat that other people have experienced similar weirdness, even though we are all Zoom pros by now. I think, you know, keeps us on our toes.
Okay. Well, again, I apologize nonetheless. So what you should be seeing now is the slides. And if I just now, and they are advancing.
Yes.
If I do that. Yeah, okay, great. Okay, so I am basically hoping to give just a little bit of framing for the discussion later on in what I'm talking about today. And what I'm going to talk about is what we are calling at the AIDC a national agenda for research software. And in fact, I'm mainly going to focus on one of the objectives of that agenda, which is what we call C research software, which is turned into a project under the research software program at the AIDC to focus on visibility of software. So in June of last year, the AIDC released a draft agenda for research software for Australia, and then over several months validated it with the community. We see research software as a critical enabler of data's value, but we also don't see it valued as such. This draft agenda was seeking to address a vision for recognition of research software as a first-class output of research. And that is that it holds the same or equivalent status as a first-class object in research, which is essentially research publications. A final version of the agenda incorporating feedback was released in March this year. I'm not going to cover the whole agenda, as I said before, just that single objective around greater visibility. So the term research software is used to refer to software used and created in a research context. But the agenda is actually built around outputs. If we're recognizing research outputs, then we're talking about outputs. So at the same time, it's pretty rare for software to stand alone. So use is always a part of creation when we're talking about software as well. We use different terminology in the draft, but pulled back to the following terms shown in the slide to describe the different kinds of software. And I'll use these terms today. But let me just say, I am not just referring to the conventional understanding of these terms. These terms here are in contrast to one another. So analysis code is the term I use to refer to software or code that captures research processes, methodology, and methodology, that is the steps taken for tasks like data generation, preparation, analysis, and visualization. Prototype tools demonstrate a new idea, method, or model for research, critically for other people to use. Research software infrastructure captures more broadly accepted and used ideas, methods, and models for research. Again, this is really intending for other people to use it. So the image looks like a stack because it is. Software at the top uses or builds on software underneath of it. And not shown is the abundance of software used in research, but is not a research output, or at least which is not seeking recognition as a research output. There are other models of research software out there. This is actually informed by Conrad Hinson's software stack in his paper on dealing with software collapse. And I quite like the more detailed framework presented last year at the Collegeville workshop by Neil Chu Hong and others called A Framework for Understanding Research Software Sustainability. But 3 is a nice number, so this will do for now. So next in the agenda, we sketch out a set of personas that directly or indirectly shape software. These are the makers of software, which we actually split into 3 different labels to correspond to the different types of software. And of course, users of software have quite an influence on software as well. Then perhaps a little too flippantly, we group together all the various roles involved in the many types of support needed for software across different stages. And again, perhaps a little too flippantly, we group together all the various infrastructure providers and then all the various people in a position to generate policy or otherwise influence software. And these gave us 3 different personas that are actually quite multifaceted. And this is because the actions upon them in the agenda are actually quite similar, even if the context in which they perform those actions is actually quite different. So then we arrive at our 3 challenges, which are all oriented around the makers of software. So we have the people who are making analysis code struggling with making their research practices more transparent. We have the people who make prototype tools struggling with enabling broad impact through quality software, because that's usually done in a funding window. They have to get it out quickly and demonstrate what they're doing. And then we have the people who are maintainers or developers and maintainers of research software infrastructure, that kind of longer-lived pieces of software, struggling with basically the lack of support for the existence of research software infrastructure in the first place. And so when we think just about that goal state associated with visibility of software, what we're seeking to address with that challenge is that research software should be shared, published, or otherwise made available upon creation, that it is cited or identified in reuse. There is a bell going off in my room for some reason. I hope it's okay. I'll keep going. Or that it is captured in data provenance or in workflows. And so now if we take that goal state and then think about who can or should do what to achieve that goal state, we get the following division of labor. So users of software are actually going to have to cite or otherwise acknowledge their use of research software. The makers of software must make their code available, and they also need to clarify their preferred form of citation through the metadata mechanisms, particularly that Moran was talking about previously. Those people that we call in the breakdown supporters and infrastructure providers must enable tracking of outputs. They must enable citation. They must enable code availability, and they must enable the existence of provenance. And policymakers must formalize emerging norms around visibility. And then taking that group as a whole, or looking at those persona types and possibly within them as well, communities of the above must form to address these changes. So if we jump back again to our goal state, another way of thinking about this detail is the mapping of relationships between objects. So I'm going to do it from the bottom up. But capturing research software in data provenance means making links between the software used to handle, transport, or transform the data. Workflows can capture the links also in analysis and possibly visualization as well. Citation is the act of linking a paper to software use or acknowledgement of that software. And I have to put a quick caveat in here to say that it could be a citation of software or a citation of a paper about the software, which would actually be a link between a paper and a paper. And finally, code shared, published, or otherwise available is actually the raw material we need to link the dependent software to software again. So that's a link between software and software. Or I've put it all in a table here, but I'm going to shuffle on from this. And we can come back to it if we want to. And so currently to act on this agenda, so turning to what we're actually doing in the ARDC to act on this agenda, we're focusing on cohering the relevant community to act on some of these aims. Last year, Paula, who's on the call, along with the co-chairs, established a new visible research software interest group. And we are looking to gather evidence to help us understand what role national information infrastructure might play to increase visibility. And we're going to do that through a survey of researchers to actually find out how they do go about finding research software, which is launching very soon. And then finally, well, it might not be my final point, but if an outcome of this working group session is revisions to the Scholix schema to include software, then what I'd like to do in the next 12 months is to produce a demonstrator within Research Data Australia to show how this might work. And also in this coming financial year or the next 12 months, we're looking at activities to mature guidance for visible software. So that would relate to the various types of publishing that are appropriate for those different classes of software that we were talking about before. And also activities to mature the tracking of software creation in Australian research institutions. And I would say actually just being here today and participating in a discussion like this is actually a step in norm forming that might guide policy in the future as well. All right, so that's me done. Thank you.
Brilliant, Tom. Thank you very much. You prevailed despite the circumstances. That was really helpful, and I think that was a really it was a really sort of clear-sighted overview of how sort of you plan to take this forward at ARDC. And I think like a lot of the I would say like a lot of the points that you mentioned resonated. So I think from the from the Crossref side, we were sort of nodding along whenever you were talking about sort of relationships and including that information in workflows, which is something that we'll pick up in our slides as well. So thank you very much. And as I said, we'll open everything up to discussion at the end. But yeah, thanks again. I will. Okay, so I'm going to I'm just going to talk through some sort of frame the discussion and give a bit of context about where we are with Scholix, and I'll talk about those relationships as well. Said I know that, and deliberately so, this is why we're having a joint session. Some people might not be really familiar with Scholix or be interested in finding out a little bit more. We get questions from people about, can I join Scholix? Is this something that I sign up to? Is it, is it, what can I do to participate? And I think the main thing is to communicate is that Scholix it's a framework, and the aim is to standardize the exchange of this link information between scholarly infrastructure providers. Initially, the focus has certainly been, thus far on articles and data sets. It's a model to be able to transfer and to exchange information on links, on scholarly links in a standard way, and also sort of a recommendation and provision of those exchange formats and protocols. And again, you can link to, we can share those, the slides are shared in the document, but you can dig into it in a little bit more detail there. But on a higher level, why did we need something like this? Why did we need a standard format to be able to, as infrastructure providers, why did we need a standard format to be able to exchange, for example, links between articles and data, or links between the data and the articles themselves, or even links between between data sets or between other items. The problem was that if you can see the slides on the left-hand side, this is sort of what the ecosystem was like before. So, you know, maybe a repository was sharing information with a publisher in a specific format. Different publishers were sharing information with different repositories, again, potentially in slightly different formats. Data centers were doing the same. So you created a lot of these like little sort of individual pathways of information, but that it wasn't consistent and it didn't scale, and there wasn't a way to kind of do that. It wasn't a way to be able to kind of compare and share the information. And again, what those little pathways mean is often the information is shared kind of privately, as opposed to being exposed in a way that we can all use it to benefit our communities. So having a standard set of guidelines for exposing and consuming the links, supported by hubs like Crossref, DataCite, OpenAir, means that repositories, data centers, publishers can all feed that information into the hubs that they work with as your community, as their communities. And then as one of those hubs, we can share it with with the community. So often the folks who are sending us those links also want to consume them, but we can also exchange them with folks like DataCite and OpenAir to be able to build that bigger picture of the context in which research is being used. So that's quite a grand aim, but a lot of these things, it does come down to just being able to share information in a standard format and in an open way so that it can be reused. The schema itself, the way that we've implemented it at Crossref is we've tried to keep it fairly simple. There's a source object that you can identify using, in our case, we use the DOI. There's the target object. So again, an example would be maybe in our case, the target object would be the DataCite DOI that's being referenced in a research article or a preprint. And then we link those together using one of a set of relationships. And the inference is that then if you want to go and find out more about that item, then that metadata is openly available via one of those hubs. There are more sort of subtypes of the information model. Again, in bold here, you can see that we've highlighted object type. Again, that's important if we want to be if we want to look into not just say a Crossref to DataCite link, but if we want to make the distinction between what's a data set, what's software, what's a preprint, and to be able to make that again, to be able to use that for our for sort of downstream purposes. Said a little bit more about the relationship types. So those relationship types, they're chosen from a Scholix controlled vocabulary, and you can see in the values column the ones that Scholix currently supports. So is referenced by, referenced, is supplement to, supplemented by, is related to. And that's based on the DataCite and the Crossref vocabulary terms, plus one generic. So those are the relationship types that we currently support, and the aim is to provide a common set of standard values, so reflecting sort of common scenarios and common ways that that you would want to link between articles and data. But as I said, we're going to pose that as an open question in a couple of slides' time. So said the focus of Scholix has been on linking articles and data sets. That's what our communities use it for today. So I think the question said that we wanted to pose is about using it to link to other research outputs. Certainly, when we look at some of those hubs that I've just mentioned, in DataCite's event data service, they can currently see for just over 4,500 events between software and data, and around just over 8,000 events between software and articles. And there are a few examples in the slides. In Crossref's event data service, we're seeing sort of a growing number of events between articles and data being registered since we started to collect that information sort of more cohesively since the end of last year. But as part of that, we can also see a growing number of events between articles and software. So still low at this point, but about 500 between, say, articles and software and Zenodo. We can also see links to software in Figshare and sort of being registered by publishers in connection to specific journals. So again, I've that +1 article links to software in Zenodo, and we're able to expose that via event data. And finally, OpenAir. Again, you can see that predominantly dataset to dataset links, but have also been interested in being able to see those data to software and publication to software links in their Scholix Explorer interface. So I guess it's something that's already happening, but we don't want to end up sort of too far down the track before before making sure that we discuss this. But I think the good news is that this is already supported to an extent, and folks are already working on it. And I think from the perspective of Crossref and working with our publisher members, I was talking to Chris Erdman at AGU, and he shared with me some slides about what they're trying to do at AGU to be able to better support software. So talking about providing information and documentation for authors to support them. And again, just in the slide to the bottom right, for AGU papers published in 2021, 27% of those were mentioning software availability. Their editor of their, and I can't remember what the acronym stands for, but for their James journal, where the editor is really advocating for this, they could see 62% of papers mentioning software availability. So this is something that publishers are interested in starting to support. So again, it sort of speaks to the fact that we want to have these kind of downstream recommendations in place so that these can be built into our workflows. So in the last couple of RDA plenaries, we discussed that there would be value in expanding Scholix to support other resource types, specifically software. Said, and again, that's part of recognizing software as a first-class output of the research process. And again, I think that's consistent with a lot of what Tom and Maureen explained earlier in the process. We know that there are other conversations in the community happening around this. Dan Katz was joined one of our sort of Scholix sessions to talk about this. He's been doing some really good work with lots of different groups, and specifically Force 11 to be able to further conversations about that. And Neil also flagged up work from the software source code working group, again on use cases and identifier schemes for persistent software code identification. So I think what we want to stress here is that we're that we're not working in, we're not looking at this in, without considering the other work that's been done on this. But, again, there's a question, is there work here that that we can use to inform our position on software citations? I think this is sort of, again, what we wanted to kind of set up in terms of a discussion. We're proposed something that we could do is we could add the object type name software and start to support that via the Scholix schema. In the data site metadata, the most commonly used relation types for software is supplement to or is version of. So again, the question is that relevant? For software, is there something else that we could do? At Crossref, we currently recommend adding links between articles and software in the same way that we do for data. So adding those in the reference lists in the metadata, because our reference lists are all openly available now, which is great. Or via relationships metadata. So using is supplemented by for data or software that's generated as part of the research results, or references for related associated data or software. And I think both the data site and Crossref are similar in that we have lots of possible relationship types. So just sort of a selection here. So, again, is there one of these that would feel like a better fit? And similarly in Crossref, and I also know that we want to do a little bit of work in terms of like clarifying how these are used and potentially sort of refining these a little bit. But as with all of these things, it should be a good thing that these grow over time, because we are trying to support more different types of relationships and represent those in a machine readable way. So before jumping too far along, Helena, did so cool. Thank you for dropping the comments into the chat. But I think at this stage, I'd probably like to sort of go ahead and open it up for discussion. I feel like we sort of throw in quite a lot of information at people there. So if we want us to kind of skip back through the slides, if this has kind of prompted sort of ideas or questions on your part, then yeah, let us know.
Yeah, thanks, Rachel, and thanks. A lot of information and a lot to think about. So maybe for the discussion from a Scholix point of view, I think there's a lot of work happening around software sharing and software citation, but I think a lot of the work in other groups at the moment is until the point where software is cited. And so that's kind of the point where Scholix comes in, because what we do is about how that information is then passed on through different systems. And so we are really trying to see, should we be making adjustments to the Scholix schema to ensure that those links between software and other outputs are available to different systems. So this really happens at the point where someone is already citing software in an article, or is already saying, when data are being deposited, look, it's related to the software, and then how do we ensure that connection is established properly and has its downstream effects? So that's really the thing we're looking to get some guidance on. Are there any initial questions or comments on that?
Yeah, so one of the things I was thinking about was that, the term software registries gets used in the research software community to refer to a range of different platforms that have a range of overlapping functions. But one particular subtype that I'm thinking of are those registries that serve as a mapping between software and papers that describe the software as well. So they serve to direct researchers to both the scholarly record as it relates to a published tool and the software, like the actual software itself. And it makes me wonder if they could become an authority in Scholix and provide useful mappings back into the system as well. And I would anticipate that there would be a similar, you know, a similar action around the relationship between data sets and data articles potentially as well.
Okay, thanks. I think that makes sense. And yeah, we didn't get to Rachel's last slide, but that was sort of a call for action, because one of the things that we'd like to do next is sort of set up a subgroup of people that will really dive into this and work on the schema update. So we wanted to get some initial thoughts from this group during this plenary meeting, and then afterwards meet with a subgroup of people to really go through the whole schema in detail and see which adjustments we may want to make it better suited to also work for software.
I have a quick comment. I think it's a good idea to add the type software. I didn't know it wasn't there. So how do you describe software now before adding the software? What type of object was it?
So I think, okay, so I think this is maybe a slightly complex. Currently in the current version of the Scholix schema, you can only choose between articles and data sets. However, in the actual implementations that, for example, DataCite and Crossref have, software does exist as an entity. So therefore, we do have numbers on how software is being connected to other things. And I think that's also what Rachel had on one of the other slides. I mean, it's already been done. We know that. And it's done in a way that's similar to what we're describing in the Scholix framework. It's just that we're currently not making an explicit recommendation in the Scholix framework. And so I think that is what we like to do here. And I agree that adding software as an object type is sort of a no-brainer to start with, because that complex question is, okay, and then which relation types are most suitable to connect software to other things? Do we sort of keep it simple and use what's already there, or are there other types that are very suitable for software and we should be making a more explicit recommendation to use those relation types? So I think that is more of an open question for us right now.
From my experience with the HAL National Archive and with CodeMeta, there's one relationship that's very important, is the reference publication, which is the publication that describes the software. So it can be referenced in many different publications, but there's the one publication that describes the software. Normally, normally in some institutions, this is a practice that is used. So this is a link which is stronger than the references toward of the software, which also exists. If you look at what SWMath is doing, I don't know if you know SWMath. It's a registry for mathematical software. It's a very elaborate registry, which is only for software records in the mathematics domain. And they do kind of a manual or semi-automatic creation of this metadata from the articles. So there's also a big registry for mathematical articles, and the SWMath is using this database and is referencing all those software the software titles, and inside you have the citation that was that cites the software, but you have a special relationship, which is the one that describes the software, which might be the same authors or the same team. Yes.
Yeah, actually, that is I'm sorry, Tom, you want to go first?
No, go first. Yep.
No, I was just going to comment on the first thing you said, Maureen, about the importance of the paper that describes the software. because actually this is something that has come up in previous Scholix discussions about data as well, that right now we use the same relation type to indicate the relationship between an article that describes the data and an article that reuses the data, and that maybe we need to consider having different relation types. So if that's also an important thing for software, that's then maybe something we could consider more generally to make that recommendation that it's not the same relation type, depending on whether it's sort of the primary paper or a case of reuse. So I think that's definitely an interesting thing for us to think about.
I was going to point out that CFF files are actually more often than not creating a link between a preferred citation form and they're actually located at the point of where the software is developed, if they're in the repository. And so inadvertently, what they've done is created a mapping between the developed version of the code and a preferred, probably paper, but sometimes an archival snapshot, sometimes both as well. So that seems like a very useful source of, I mean, if you look at the growth of the uptake of that particular metadata file, it's basically going straight up at the moment. So that's well worth exploring in the future.
Okay, yeah, it would be good probably to also put all of that in a notes document so that we have a good overview of all of these things when we look at this after the session.
I've also added in the chat a link to an example on SW Math, just a specific example, but you can search for any other example that you might find. So if you go, I see, Rachel, that you have opened the link. So if you go down, so here you have general metadata, but then downwards you have the one standard article, which is the relationship that we are talking about. Yes, just the first line, and then below that you have all the other publications where this software was cited, referenced, mentioned.
And do you have any thoughts already on the best way to distinguish through relation types, or is that too detailed?
Well, this is already a major distinction between the reference publication, which is also a metadata property in the code meta vocabulary.
Mm-hmm.
And as Tom said, there's in the citation file, there's the preferred citation. So I don't really like this practice of having a preferred citation, which is not the software, because you have the possibility to put in your citation file the this information of citing something else, so the article, because citing software is not a practice that's done, and the value of the software is less than the publication. And so by giving this option, this is a good thing for the researchers, but it's a less good thing for software in general in this ecosystem, because then people will continue cite the article, even though it's the software they want and should cite. So, but it really depends on the context, and here I'm just saying my personal opinion about that.
I would say though that the more that we know the mapping between a paper that describes software and the software itself, the more we can make that change, right? Like it levels the playing field essentially when we have that information en masse. So the mapping itself is actually really useful. I could go back, for instance, and we have the equivalent of the REF in the UK. We have the ERA, Excellence in Research in Australia. Oh gosh, I've probably got the acronym wrong, but it's the kind of multi-year tally of all of the outputs, and software is not an allowable output in that format at the moment, but it's absolutely chock full of papers about software. But what I can't do without the mapping between a mapping that tells me that this is a paper that is about a piece of software that's been published, is I can't point to that evidence base and say, well, actually 10% of the papers that were put forward for the ERA are actually software papers. So we need that information as a transitional step towards software citation itself.
Yes, I agree.
And I think there's also a question in the chat from Paula, probably for Maureen.
So no, it's not a DOI because it's a registry and not a publisher. And most of those, some of those can be published software. So they are using an identifier, a soft SWMF identifier. So what you can find is that if you go up in this on the top, you have the URL to the current project, the archive, Internet Archive one. And when you go on the code, you'll get to software heritage. And we're working now with SWMF to have a better identification of the software with the SWID. The problem is that the semipar, for example, is a project level record. So it's difficult to identify a specific artifact, which means that you have a collection, a very large collection of artifacts that can be identified with semipar. So this is really a complex situation where you have those registries with high level, project level records, and then identifying one specific artifact will be difficult. So for the question of the DOI, as being a registry, I don't think that they can or need to produce a DOI, but if the DOI is already generated for the project, that's will be available on the record.
Tom, I think you your hand up.
Right. Well, so that's where, you know, there's a sort of question of whether we explode the objects that participate in this larger schema, or if we conflate categories as well. That's why I went through introducing those 3 different types of software, because there's different relationships with publications for those 3 different types of software. So what's associated with analysis code is most likely to be a one-shot version of that software that isn't like a living project, that has a close association with data and a really close association with a research publication. The second type, the prototype tool, is likely to have that relationship between an article describing the software and the software itself, because what they're essentially doing is promoting the tool for reuse, and then it may then go on to have reuses, in which case people would go on to cite that software when they reuse it. And then the third type of software is assumed to be a kind of more stable, necessary part of the larger research ecosystem, where it's really common for, say, a methodology section in a paper to reference that they used a set of tools or so on, and in which case they might actually prefer to refer to the project in an ongoing basis. Say, you know, we use this semipar set of tools to do our analysis. That's what we always do. That's what we intend to do in the future. And it doesn't necessarily make sense to talk about a moment in time version of the software, but to refer to the software concept itself. But that does open up the possibility that we're going to you know, take a really simple schema and kind of make it a nightmare fuel. And maybe we don't want to do that. I guess the other thing I'd say is that, you know, a relationship between 2 objects is much less complicated than in a relationship between 3. And that was something that I was getting at in that other slide, is that the relationship between data and software, for instance, could be on either side of the data. It could be in the software was an actor upon the state of the data before it was published, or it could have been after the data was archived, for instance, that there was a set of tools that were subsequently used on that version of the data to do a range of analysis. That relationship itself is not necessarily one of citation. It's probably going to lean on identifier schemes more like the one that Moran presented, where we're kind of trying to make mechanical and very precise reference to exactly which version of the software and which part of it perhaps was used at which stage as well. So yeah, sorry, this is all problems and no solutions.
But I agree with you, Tom. It's complexifying maybe something very simple, but with software, we should keep in mind that there is a difference between the concept and identifying the part of the software which is at the high level, which is not a digital object. So here, Semipar is not a digital object; it's a community, it's a project, it's a team. But the digital objects are the specific versions. So in terms of granularity, there's we have normally that I haven't shown here in the presentation. We have a pyramid of different granularity levels, where the first granularity level 1 is the project, and then you have 10 different categories of granularity levels, which is getting bigger and bigger with more and more items. So at the lowest one is the code fragments, the algorithms. You can find it in the software. You can identify them, and you can have many in one piece of software. And I'm not sure if that's how to translate it into the schema, or use just is part of. So a type of artifact is part of something that is bigger. And also something I wanted to say is that the type software is a bit ambiguous. What is this? What do you mean when you say software? Is it software source code? Is it the software project? Is it the software executable? Is it really the part that is a digital object to connect to, that was used with the data, with the application, or is it really the project, as Tom said? So having in mind this complexity of the software can complexify things, but also clear up that we're talking about different things. So software is not one thing, it's different types of things. So clarifying between software project and the software version, for example. And so I've put in the chat another link. This is a blog.
I think we lost Maureen for a second. We see some movement.
We have her screen, but not her,
Yeah.
voice.
Yeah, it looks like it.
She might have just dropped out. Yeah.
Yeah,
Yeah.
I think she did.
I wanted to raise a possibility, but maybe I'll repeat it when Moran comes back again. But one pragmatic thing that we could do is to just take analysis code as in scope for a first phase, because I think it's probably the most populous kind of research software, and it doesn't have all of these problems. It doesn't have versions. It doesn't get identified as a project or anything like that. And it's got a really close relationship with papers. Moran, sorry, you're back.
Yeah, sorry, it just disappeared.
Good to have you back.
It was strange. Zoom was kind of poof. Okay, sorry.
I was just saying that maybe a pragmatic first step would be to focus on just analysis code, because it's the more common type of software It's got the closer relationship with paper, with publications and data, and it don't shoot me. And it doesn't have these issues with software, like differentiating software concept from software source code and various other forms as well. It's like a one-shot piece of code that doesn't tend to, it's just a record of process in relation to research.
I think that you might shoot yourself in the leg by doing that, because you will do all the work you need to do for just one thing that is not, well, maybe it's very common to have it, but it's really not representative of all the software that is in the academic ecosystem. So I think that you will do a lot of changes for just this type, having only this type in mind. And then when you come to the big problems, you need to do again the same work, and even changing the first thing that you have integrated, just because you haven't taken into consideration the software is very very different. And I know that in the in Australia you have working on the prize for the open source software in research, like we have done in France, and it's surprising. In France, at least, we had this prize for an open source research software. It was given in February. It was the first prize, national prize, and it was very surprising to see the diversity and how the community is rich with different types of software, and so I think that you will be surprised that there is a lot of software to take into consideration. Yes.
No, let me, you know that I care about all of the software. I guess I'm trying to explore ways of playing the long game on this one, and also making changes to Scholix, the Scholix schema that are perhaps not too big early on. So I guess I am thinking about it as an iterative process, and that this suggestion was simply about really coming at it from the Scholix side of like, what's the smallest change we can make to see if it works, and then we can start to tackle these bigger, more complicated problems. It's not that I'm trying to ignore that part of the software world. It's super important to me too. In fact, it's, you know, if I had to be really blunt, I think the record of process is so much less interesting than the kind of amazing ideas that are caught up in software prototypes and in software infrastructure tools that are created for other people to use. That's really the exciting end of the spectrum.
So maybe with an eye on the clock, I think we're really hoping, Tom and Moraine, that both of you would be willing to join the subgroup to discuss this in much more detail following this breakout session, because I'm sure there's much more we can talk about. Of course, anyone who's on the call today, we really welcome your input. So please, if you're interested in joining the group that will look at the Scholix schema, then please put your name in the notes document or in the chat. Are there any sort of final questions before we wrap up? Anything that wasn't clear today, or any suggestions you have before we take all the input and move forward with it? Just want to give everyone a chance for some final words before we wrap up the session. Okay, in that case, I hope you know where to find us. We're always happy to hear from you and get additional input. I see a last comment. Just a comment to the last thought. In my mind, the minimum viable product is adding software type and license for research software. Okay. Yeah, so you think the main thing is sort of in the object, and then the license, and then the relation types, what we have may be suitable already. Okay, that is a useful comment. And of course, we're also missing some people today because of well, all the time zone challenges. So we'll definitely be reaching out to those people afterwards as well to continue this conversation. And hopefully at the next plenary meeting, we can report back on the changes we made to the schema. That's definitely the timeline, that before the next RDA plenary meeting, we'll be making some updates. So we look forward to reporting back to you. Rachel, anything else from you?
No, just to say, you know, obviously thanks to Tom and Maureen for presenting their perspectives, and for I think for reinforcing those perspectives in the discussion, and you know, for some of the input in the chat as well. Paula, you know, I appreciate that comment on, you know, that you just made about sort of licenses, type, relationships. So yeah, more to come.
Okay, thanks so much, everyone. Thanks, Maureen, Tom, and Rachel for your great presentations.
Thank you for proposing this